Leave Claude Code idle too long, and prices can spike up to 20 times.
I had no idea just stepping away could make it cost so much more. Renka, I need to tell you something. This weekend, I was running Claude Code between errands around the house. Went shopping, had dinner, watched some TV, then came back and picked up where I left off. Then Sunday night I checked, and the tokens were disappearing way faster than I expected.
How long were those gaps, actually?
Now that you mention it, each one was probably well over an hour.
That's it. I think the prompt cache TTL was expiring every single time.
TTL?
That's the cache's lifespan. 1 hour on a subscription, 5 minutes on an API key. If you leave it idle past that, the next turn has to reread the entire conversation history.
All of it, like everything we've said this whole time.
Right? With a cache hit it's just 0.1x, but a rewrite pushes it to 2x. So basically, however long you were away turns directly into cost.
So just stepping away was quietly racking up the bill.
Today let's go through how that works and how to deal with it. So to start, the model doesn't actually remember anything between requests.
It doesn't remember, but it responds based on what we said before.
That's because Claude Code resends the entire conversation history every single time.
So it's reading everything from scratch each time. That sounds pretty heavy.
Right? And it's not just the conversation being sent. There are 3 layers. First, the system prompt, then the project context like Claude.md, and last, the conversation history. All 3 get stacked up and sent in full every time.
So the longer the conversation gets, the more it keeps sending.
That's why without a cache, every single turn runs the whole thing from scratch.
So once it expires, all 3 layers get reread.
Prompt caching only applies to the part that matches exactly from the very start of the request. If even one character changes partway through, everything after that gets recomputed.
Just matching from the start, it's not per file or anything like that.
Right? There's no such thing as a per file cache.
Okay, so then what happens when you edit a file?
That's fine actually. Rereading a file just gets appended to the end. The cache built up from the start stays intact.
So since it's just appended, the beginning never changes, it's safe.
Exactly. As long as you're just writing code normally, the cache stays warm. There's a part about when the TTL starts that's easy to get wrong. It's not counted from when the session starts. It's counted from the moment of the last cache hit. Every time a request goes out and the cache gets read, the timer resets.
So if it resets on every hit, it never expires as long as you keep using it.
Right? The problem is when idle time goes past the TTL, only the time spent doing nothing counts against you. So however long you're away hits directly.
So on a weekend where every gap is over an hour, it was expiring every single time.
Exactly. And by the way, that number of minutes varies a lot depending on the setup.
It varies depending on the environment. What determines that?
It's determined automatically by the authentication method. If you're logged in with a Pro or Max subscription, the main conversation automatically requests a 1-hour TTL. With an API key, or through Bedrock or Google Cloud, the default is 5 minutes.
5 minutes is pretty tight. Feels like it'd expire while you're just thinking.
That's why you can change it with an environment variable. Setting enable_PROMPT_CSCH_ING_1H to 1 lets you opt into the 1-hour TTL.
So you can get the 1-hour TTL even with an API key. That could really help.
But the 1-hour TTL doubles the cache write cost. With 5 minutes, it's 1.25 times. That's why the default is 5 minutes for API billing.
So whether 1 hour is worth it depends on how much time you leave between requests.
Also, even on a subscription, if you go over your plan's limit, you get billed with usage credits. When that happens, it automatically drops down to a 5-minute TTL.
It switches to 5 minutes the moment you go over the limit. I didn't know that.
Once you're paying out of pocket, a 2x write cost gets expensive, so it switches automatically. Also, subagents always use 5 minutes, regardless of the parent's authentication.
Subagents, those are the ones called through the agent tool, right?
Right. A subagent has its own separate conversation and its own separate cache from the parent. The 1-hour TTL only applies to the main conversation, not to subagents.
So if you're using subagents a lot, you have to keep that 5-minute wall in mind.
Reading from the cache, cache_read, costs 0.1 times the input price. So if you're working normally, reading the history only costs 1/10 of the price.
So when it's not working, you're paying 10 times that.
Exactly. And the real problem is when you're writing to the cache. The write called cache_creation costs 1.25 times with a 5-minute TTL and 2 times with a 1-hour TTL.
0.1 times versus 2 times. That's a 20x difference in price.
Yeah, for the 1-hour TTL on a subscription. Even the 5-minute TTL on an API key is 12.5 times. For just the one turn right after the TTL expires, this happens. All the history that used to read at 0.1 times gets rewritten from scratch.
So the longer the conversation, the bigger that one-time cost gets?
Right? The longer the history, the heavier that first turn after resuming gets.
But that doesn't keep going forever, right?
Right. The rewrite is a one-time cost, limited to that single turn. From the next turn on, the cache kicks in again, and it goes back to 0.1 times.
So if you just step away occasionally, it's nothing to worry about?
Yeah. A single TTL expiration isn't really that painful.
But what happens if it expires every single time?
Say you're using an API key, and you're taking more than 10 minutes on every reply. If you're always going over the 5-minute TTL, every single turn becomes a cold start.
So the rewrite runs on every turn.
Right. You barely get to enjoy that 0.1x cache_read rate. Everything gets billed at 1.25 or 2 times instead.
5 minutes flies by. You'd blow past it just by thinking something through.
And the amount rewritten each time keeps growing as the turns go on.
That's literally my whole weekend, right there.
That's why the time between replies quietly matters so much. If you make a habit of sending the next request within the TTL, you can keep the cost down quite a bit. The moment you switch models with /model, the whole cache gets wiped. The cache is separate per model, so it doesn't matter even if the TTL still has time left.
So it's not just about wait time, your own actions can break it too.
And switching models doesn't only happen when you type /model.
There's more to it.
If you're using Opasplin, the model switches every time you enter or exit plan mode. That whole flow of planning, then moving to implementation, rebuilds the cache every single time. Changing the reasoning strength with /effort is also part of the cache key. That's why you get a confirmation dialog if you change it mid-session.
So that's what that dialogue meant.
Toggling fast mode on does the same thing. The request headers change, so it breaks the cache. On the other hand, connecting or disconnecting an MCP server usually doesn't break it these days. Tools are lazy loaded now, so they just get appended at the end. But in an environment where lazy loading doesn't kick in, everything gets blown away every time you connect.
What about when you block a built-in tool like bash with a deny rule?
That breaks it too. Tool definitions live in the system prompt, so any change to them takes effect. What doesn't break it, on the other hand, is something like /rewind or calling a skill. /rewind just goes back to a point that was already cached, so everything up to there can still be reused.
Sounds like it's better to wrap up a chunk of work before messing with settings.
Sometimes you pick up the next morning where you left off the day before. In that case, that first turn ends up strangely expensive.
The next morning, does something change while you're asleep?
It breaks even if you haven't touched anything yourself. The classic example is a Claude Code upgrade. A new version comes with an updated system prompt and updated tool definitions. The start of the prefix changes, so the very first turn after an upgrade means a full rebuild.
So if auto-update kicked in, it's already broken and you don't even notice?
Auto-update only takes effect the next time you launch it, so it doesn't apply mid-session. That's why the first time you spin it up in the morning, you're suddenly on the new version.
So the same thing happens when you resume an old session with /resume too.
Right? Resume restores the conversation history, but the cache is long gone by then. And if an upgrade happened in between, the system prompt is different too, so it's completely uncached.
How expensive does that actually get?
Suppose your history has built up to 100,000 tokens. In that case, all of it gets reprocessed at the right token rate. It's even written in the official docs. The first turn of a long conversation resumed after an upgrade can end up being the single most expensive request.
So just trying to pick up where you left off, you end up hitting the most expensive turn there is. How do you even tell when the cache has expired?
You can see it in the status line. There's an info bar Claude Code can show at the bottom. The cache info lives under current usage inside context window. Cache read input tokens is how many tokens got read from the cache. Cache creation input tokens is how many got freshly written.
So the ratio between those two tells you whether the cache is actually working.
Right? If cache read is high and cache creation is low, the cache is warm. If cache creation is high instead, that means a rewrite just ran.
Does the number update in real time the moment the TTL expires?
Actually, the number doesn't get finalized until the next API response comes back. The display doesn't change the instant the TTL runs out. You only find out once you send the next turn.
So there's no way to catch it ahead of time. You can only tell after the fact.
If you want a quick display with Bash and JQ, you can write something like this. Just pull cache read and cache creation out of the input with JQ and echo them side by side.
So once the numbers are visible, you can also tell how much history has piled up before you step away.
Right? Just having the numbers laid out lets you see at a glance whether the cache is actually paying off. There's something worth doing before a long break. Compressing the conversation with /compact shrinks what has to be fully reprocessed when you come back.
So summarizing the history down keeps the rewrite smaller too.
The thing is, doing it after the cache already expired barely helps. Suppose you run /compact after the TTL has expired. In that case, generating that summary itself becomes an uncached full-text pass.
So compacting after you resume just means you eat the expensive turn during the compaction instead.
That's why hitting it right when you decide to step away, while the cache is still alive, is the cheap move. Compact it quickly before you leave, and coming back is a lot lighter.
So how you spend that waiting time changes your token bill.